Good afternoon, y'all. Hey, welcome to this first stream where I decided to do a bit of a special session instead of my regular live coding streams on Tuesdays. Let's do one on Sundays and then do it not just about any old live coding thing, but maybe like try to explain a bit around developing and whatever's involved with that. And this one, first let me get a sip. Actual Karmeliet this time, so cheers. Cheers to you all. Yum yum. Anyway, as I was trying to say, first time I'm going to do this. So yeah, it's just an experiment. Let's see how this works out. The thing I wanted to show today was a bit about how, you know, when you're developing, well, you might not know, but when you're developing in a team, there's this tendency of people to do a lot of things at the same time just to increase their efficiency. But are they really increasing their efficiency is what we're trying to find out. And at DDD Europe, the virtual conference this year, Michel Grootjans gave a talk while he was explaining Flow, and it really stuck with me, and I gave the same kind of presentation to people that didn't follow DDD Europe, but I thought maybe it's worth repeating on stream as well, like live, because to me this subject is pretty valuable, let's say, valuable a thing to know and to understand. And I really love how Michel Grootjans made this thing, or this idea, accessible to developers. So what he did was he created a GitHub repository. It's open source, so anyone can clone it and improve upon it. And what he did was, yeah, just make it a little bit more accessible based on some theory as well from queuing theory, but that's maybe running a bit ahead of myself. So why don't we jump in? I'm gonna put this thing here in chat, the link, so you can follow along there. And yeah, let me switch to, by the way, I've been using a new theme. I've set it up in the last couple of days, so I hope you enjoy that as well. So let's get into it, shall we? All right, here we go. So this is the GitHub repository. I've already cloned it and made sure that it's running on my machine. So if you want to play around with it the same time as I'm doing it, you should also clone it as well. And then yeah, I'll just go ahead and start the demo. So what we have in this repository is one file, or there's many files, but there are many like it, but this one is mine. No, I'm just kidding. This is the setup.js file where we'll spend most of our time just adjusting some stuff. So what we've set up here is a board where we track our work for a one-man team or one-person team, just a developer, and there's a backlog of 50 items that all take a complexity or difficulty of 1 to finish. And then this is just a way to make sure that time happens fast. I already did a thing where I ran this job. So maybe we'll switch windows here. So this is the result of running that simulation. It comes with a graph and a bunch of data. So initially, you'll see this later, there will be a backlog of 50 items here, and the dev takes them all one by one and processes them all at the same time or speed. So it makes sense that everything here is 1. So what we're tracking here is throughput. So how many stories per day can this developer deliver, let's say. And then we've got a lead time of 1. So whenever a dev takes up one item out of the backlog and starts working on it, it will take them 1 day until it gets delivered. So that's what we track as lead time here. So it just stays constant. But so of course that's not like a very realistic situation, because not all work takes the same time or is how do you say, like is just as difficult. So let's start by randomizing it a bit. Let's say that it's an average of 1. So if we run this simulation, all of a sudden it's going to look a bit different, because now the complexity of the work is not always a single 1, but it varies between 0 and 1. So somewhere in between. And now you can see that well, the throughput, if the throughput is a high, so if they take a long time of doing that job, it will take no, sorry, if they're very fast at doing their job, then the lead time also decreases. So there's like an inverse relationship between lead time and throughput here. And what was I going to say about that? Well, basically, we sped through this backlog here just to advance time a bit, let's say. But you can see the result. Like, you can deduce a bit about the work that this one developer has done. Of course, this is still not like very representative of a single team. So maybe let's add a bunch of different work. So maybe let's do analysis or something, and then maybe let's do Q&A. Or sorry, not QA, just quality assurance. Of course, we'll also add 3 more people to do these jobs. So we've got an analyst, they can do analysis. And then we've got 1 tester, and they can do testing work. And then of course we also want to keep track of those 2 additional things. So usually analysis happens first, then there's the development that's going to happen, and then there's testing work until it's considered done. If we then run this, maybe I can already also increase the amount of work to 200. So now we've got, yeah, we will see. So if I run this, it's already a bit more of a realistic situation here. So normally the graph will update eventually as well, but we'll see that in a moment when it's done rendering. There we go. Many data points now this time. So what can we see here is a very fluctuating lead time here. And we can also see that the how do you say, the work in progress is like an indicator to where the lead time is going to go. It sort of makes sense, right? Because the more work you pick up, the longer it will take until it's delivered or added to the done column, basically. So the more we increase our work in progress, the longer it will take. And you can see that the lead time, in fact, or the knowledge that your lead time will increase trails or lags behind increasing the work in progress. So here, if we've got some work in progress at 6, that means across the entire board here. So starting from when people in the team pick up an item out of the backlog, the moment they do that, we'll start counting it as work in progress. So until it hits done, it's still work in progress because it's not being delivered, right? So the moment this increases, this work in progress, you'll see that it will increase from 6 to 7 and then eventually to 12 or 10 here. After that, the lead time also always steadily increases. And likewise, when it drops, your work in progress drops, the lead time will also decrease. So you will be delivering value much faster, right? So this is usually the metric that business is interested in, because the shorter you can make this, the faster that they can run experiments in production to verify if the customer's behavior is changed, or if whatever that they're trying to do is helping the business, basically. So that's why business, the people behind the business really, are interested in shortening the lead time. And I feel like we as developers or the IT department, we should be involved in helping them achieve this, because it will be a benefit or be beneficial to the company in itself, and so be beneficial to us as well. Why else are we in the business of developing code if not to increase business value or help the business solve some stuff by automation maybe? But so we can already see that it's quite different a graph, and I guess a little bit more representable or representative of an actual team. So now that we maybe another thing that's quite important here is that we can see how efficient our people have been at their jobs. So an analyst, the one analyst that we have, they've been 90% efficient at their job. The developer has been 84% efficient at their job. And the tester has been 87% efficient at their job. Meaning, if basically right now this is just showing the randomness of the, what's it called? The complexity factor. So now this is somewhat unrealistic as well, because usually analysis time or complexity might be a little bit less than development time, and Q&A time also might be a little bit more than analysis time. So let's fix that a bit and just come up with some random numbers here. Now we're saying that development work is twice as complex as doing the analysis. I'm not sure if that's correct, but let's just say this is the case, or it usually takes twice as long. Maybe that's a better way of saying it. And then testing it, they basically need to know how is it supposed to function, and then let's run some tests against that until we can break it or learn something new about that. So if we run this kind of simulation, we are going to see that there's a bunch of stuff piling up in front of the one developer. So there's a queue basically, and the analyst here, they are picking up work as they go, and they're just marking it as done. Now it's time for the developer to do their work, and then the developer picks up their work, and then the quality analyst can or quality assurance person, they can run their tests as a developer finishes their work. So now all of a sudden this looks very, very scary, in fact, because the work in progress just keeps on increasing, and it's because if the work of a developer takes twice as long as the work of an analyst, then of course work is going to keep piling up here, and an analyst, they can just throw it over the wall basically, and then wait for the developer to pick it up, and then deliver it to the tester to finally mark it as done. But you can see that it's a very dangerous thing to keep on increasing work in progress, because as you can see, we've also been increasing our lead time very consistently, in fact. And here you can also see that like the lagging effect has like a very serious impact. The more or the longer you keep on piling up work in progress, the longer it will take for the lead time to increase as well. So the more work in progress you'll have, the later you'll learn that your lead time has increased quite as I just say, like quite exhaustively or something. This also reflects in the tester being less efficient at their job than before. And in fact, if you just look at the metrics, we've got a lead time of 106 days. So that means the moment one item of the backlog is being pulled into our system of a team, it'll take generally 106 days until business learns about this, like the impact of that item, that work item, because that's how long it will take until it's moved into done. So I don't think business is going to be happy with a process like this. So what will they typically do is they'll see, well, obviously the problem lies with the developers, because have you seen the amount of work that they can't do, and it just keeps on piling up. So you know what, let's just add a developer. So at the cost of an extra developer, we'll add one. So everything else just stays the same. So if we just add a new developer that's, let's say just as smart as the other one, or just as efficient at their job as the other one, not including the randomness. Let's see what the result will bring now. So normally we should see the queue being much less big. You can still see it pile up just a little bit, but not as much as before. And as we wait for the tester to do their job, we can see that there has been a significant improvement here, because from 106 days we are now doing our work like in 43 days time we will learn. But still the graph sort of still looks like the same. It's just a little bit shorter in time, I should say. What else can we see? Of course, the efficiency of our QAer has improved significantly now, because there's now 2 developers doing the work that the analyst is presenting them. So we have indeed a throughput of 0.64 stories per day, so half a story a day somewhat. Here it was 0.44 stories a day. So while the throughput hasn't increased that significantly, the lead time has. Right. But like a typical decision, what we haven't included here is that, of course, a developer, they cost a lot more. So maybe, since this talk is about flow, what can we do to achieve a better flow throughout the system? Maybe we can start by introducing, where do we see that? There's like a way to set new whip or something. Where was that? Limit board whip by, I don't know, let's say 10 or something. I'm not sure if we need to do it like this or like that. That's all actually in the GitHub repository as well, so let's figure that thing out. Boom, boom, boom. Yeah, so we do new limit board whip to 10, and let's see what this brings. So instead of adding the developer, so instead of adding a new developer, let's just decrease the amount of work in progress for our team here and run the simulation again. All right, here we go. Now we can see that's work in progress limit to 10. So add the work in progress keeps at 10. So that means like throughout the entire system here of our team, we put a maximum of 10 work in progress, so 10 items in progress. What happens then to our lead time? So even though we did, the only thing that we did was decrease the amount of work in progress throughout the entire system, we have increased the lead time with like an insane amount. We've halved it when we added an extra developer, and even without an extra developer, but by decreasing the work in progress, our lead time has decreased even more. So let that sink in. If the business is more interested in things that, you know, like teach them faster for a new item that is being put in production by just decreasing work in progress, what can we achieve instead of just adding new people and even introducing new costs? So we can even put it a little bit further. So let's say what happens if we put the work in progress limit to 4 instead of 10 even? Can we maybe even decrease it further, the lead time? Let's see what this thing does. So this time with a work in progress of 4. So that means if analysis, dev, and QA, between those, they'll only have a maximum amount of 4 work in progress at any one given time. So one thing we didn't look at yet is the efficiency here, but that we'll explain even later. So we even managed to decrease the lead time even further, just by, again, limiting the work in progress. So to me, this is, how do you say that? Like, this is like an amazing revelation. It's wild. It's really wild how by just decreasing the work in progress, you can learn much faster about what you've delivered into production. And for business, this must mean an insane amount. So basically, it's the same type of work. It's the same amount of work. The only thing that we did is we made sure that by decreasing the work in progress, we'll learn much faster about what we put into production. That's the only thing that happened here. So the one thing we will notice here, though, is that the efficiency of an analyst is halved. So they're only now working at 50% capacity, let's say. So typically, you could consider that a problem, but it's only a problem. How do you say that? If you just only evaluate how efficient a single person is. Of course, it's a silly thing to measure if the one thing that you're interested in is how fast can you learn about the things that you put into production. So even though these workers are not fully efficient, let's say, it shouldn't even matter, because this is the one thing you should be measuring, in fact. Yeah, because this is the one thing that's going to be providing you with more business value. So even though they're not as efficient, it is achieving the correct result. So the one thing you should try as well is like, what happens if you even decrease it further, just to 2 maybe? What happens then? What do you expect? Just think along a bit. Is this going to be another drastic improvement here, or what? Now you can see that the analyst is even less efficient as before, but so is the tester here, in fact. So basically, there's a bunch of wait time now where an analyst is waiting to pick up new work because they're waiting for that one ticket to advance from the dev to the tester and then to done before they can pick up a new thing. So now we can see that the lead time has actually increased again. So when so that has in fact decreased, sorry, but it decreased with this as a result. So the throughput here is now a bit more drastic, let's say. So it will take a shorter time to learn about one thing, but the throughput, if you have deadlines, then this might be a more serious problem. Whereas if you look at this here, so the decrease from 10 to 4 that was only 0.02 stories per day slower, let's say. But here we're decreasing with 0.10, so maybe that's more considerable. Okay, so of course it's not like we say, it's not a silver bullet, but there is one thing that we can still do to increase a bit the efficiency of our workers, and that's of course when they say that, well, half the time they're waiting to pull in new work, what will they do the other half of time? So we've been running this experiment under the assumption that an analyst can, so this is let's say that this is an analyst, oops. This is a developer, and this is a tester, so all with one specialty. One thing that we can add as a way to maybe improve the work is by making all of these a little bit more T-shaped. So in the time that an analyst is taking, so half their time basically, that they have to wait for a new work item to be, that they can pull in. So they must wait until these things progress further down. What if they invest their time a bit in learning about development? So let's say that this is here an analyst, and eventually maybe they can work as a developer at half speed. I'm just saying. So what we're doing with this is that our analyst is now also skilled at half the time a normal developer will take it to pick up work as well. So basically they're also doing the job of a developer, but then at half the speed. And maybe we can say the same about a QA person. So like this maybe. And then we'll keep the rest just the same. Maybe we'll go back to adding a whip limit of 10 maybe or something. So then we can compare the whip limit of 10, this one, with the next run and see where we come out when this happens. So basically this is like in the most how do you say it, like in a general sense, the analyst has invested in their growth by learning how to also pick up development stories, or help out at least with those things. And same for our tester. Of course these are just numbers, but what happens, huh? I don't know if some of you noticed, but the work in progress here of the stories, even though it was set at 10, I don't think it ever went above 4. So now our lead time, let's see, if we compare it with the 10, so it goes from 20 to 7. So it might be a bit unrealistic, because it's not from the one day until the next that an analyst and a developer will understand how to code. But maybe this is also like a good indication, saying that when an analyst or a QA are waiting for work, then they can also help pick up work for the development part. Maybe the 0.5 was a bit too generous. I don't really know. It's just numbers basically, right? So now if we can put a number on the skills of our people in our teams, that we can actually use a simulation. But no, really, the idea is that after a long time, so when you invest learning, or when you invest as a company, if you invest, or as a team, if you invest in learning for the people that are waiting, so instead of having them pick up new work, have them invest in learning new skills to help out with the team, then you can even increase or decrease, sorry, your lead time even more with just the same team. So your throughput suffers, even though your throughput suffers, I want to say, your lead time still increases a bunch. There's a bunch of theory behind it, so yeah, maybe we can show like the perfect situation is where I forgot how you did the full stack developers, let's say, or like people that are completely block shaped, so not even T-shaped but like block shaped. All, so you just do all. There we go. And then the comma dev things we can drop. So now we only have full stack or block shaped profiles, not even T-shaped or E-shaped. So I'll spam some links, or I will navigate or do some Google searches to explain these terms maybe. All right, here we go. And we'll do, I don't even think the whip limit matters now. Let's go for it. You can see already that, of course, their work in progress will be just 3 because they can pick up all of the work. And so if there's room for the team to work on a new ticket, then one of them will pick up that ticket, they will analyze it, then anyone, it can be the same person, will develop it, and then again anyone, it can be the same person, can test it and then deliver it to done. And in this case, of course, it's quite insane how fast that the team works, and also how fast they can, their lead time really is. So of course this is a utopia. Not everyone in the team is going to be, first of all, equally skilled. And I don't think that everyone, or that's not my experience at least, not everyone in your team is going to be equally skilled at all the things. So not at analysis or requirements gathering, UX design, testing, or the operations part. Like, it will be quite broad, the difference. But this is a good, how do you say, like a good direction to work towards while you are limiting your work in progress, in fact. So yeah, that's about all there is to say. Basically, the theory comes from queuing theory, basically, but there's like one important, maybe there's a link as well. Yeah, of course. So Michel also said, like, let's say that even if or like a way to increase the skills of your entire team, you can swarm or do mob programming, for example, where you include your testers or your analysts even, and that way they will learn their new skills and evolve to the quote-unquote ideal state where everyone is fully skilled, let's say, in all of those things. But I was actually looking for a link to Little's Law. Here we go. So Little's Law is part of queue theory, where is it explained properly? Maybe I've added a link in our README here as well. I'm not really sure we did. No. Anyway, Little's Law is just a law basically that's saying the queuing time, or well, not queuing time, but the influx of the speed of influx of people and or things in the system, work in the system. Where is it? Blah blah blah. The average number of customers in a stationary system is equal to the long-term average effective arrival rate. So how fast people enter the store or customers enter the store, multiplied by the average time that a customer spends in the system. So the W here is the work in progress. So the average number is the amount of stuff, basically your throughput, the arrival rate, how fast you can pull in new item or new work, and then W is the time, average time that a customer spends in the system. So if you limit one of these, I hope I explained that properly here. No, so actually L is a work in progress. So L is the average of number of items in your system, of course. Then the lambda is the average arrival rate. So I don't really know how to express that in it's throughput basically. Yeah, it must be throughput, and then times the lead time. So if we know that if we want to improve our system, modifying the throughput, how do you do that? By working more efficiently, you would say. Maybe if you're trying to reach a deadline, it would be like dropping unit tests or having everybody work parallel at the same time, and then you will increase your throughput. You might, but you might not. Or you might do it short term. The other way you can play around with that is by modifying the W here, the lead time. I don't think you can actually do that, because lead time is like a direct consequence of that thing. We saw that there was an inverse relationship between those things. But the one thing that you can more easily play with is the work in progress. So one metric or one thing that you can easily modify from today until the next day is by just decreasing your work in progress, and you will improve your lead time. And while you do this, you can steadily also increase the learning of your team members so that they will become more efficient at their job, and then also improve the lead time by doing that. Cool, eh? So yeah, there's a science behind it. It's just maths. If you, maybe I'll share here the link as well. There we go. What else is there to say? I think that's about it, basically. That's it. Oh, thank you for following Motoko Hadari, if I say that correctly. But that's basically it, yeah. So if you want to play around with this simulation, you just go to Michel's GitHub and start playing around with it. Michel even has put like what's like a to-do here, where he's guiding us a bit to what can we do to improve this repository. Maybe we can introduce a way to include swarming, like what happens if you do swarming. Yeah, of course, I can paste the GitHub link in chat. Here you go, friend. And yeah, some other things, maybe introduce pairing or mob programming, comparing two simulations. We've been doing it manually by just tabbing through these results. But maybe there's an improvement there to be made by just being able to compare results. Damn, there was one other thing I wanted to say, Chutoch. Yeah. One an important thing that I haven't mentioned in this simulation is the fact that it's not always that a team has to wait for a new job or for picking up a new work item by a reason, or like as with the cause of being internally. So if we saw that before, like because of the development work is taking a longer time than the analysis work, an analyst needs to wait a bit longer until they pick up new work before like that one item is through into the done column. But there are other situations where work might be blocked. For example, if a developer needs to wait until integration, like there's an integration point that they need to implement, and they are depending on an external team, for example, to deliver an API or whatever. I'm sure you've been in this situation before. Then you can't do your job, in fact, and you have to wait for them to deliver their work, to finish. But in that situation, you're blocked outside of your team. Then, like, the next question arises, well, is then still a smart thing to not pick up new work? And then the answer, or the short answer, is yes, it's still a smart thing to not pick up new work. And the reason for that is that the more work you pick up in your system, the more chance that work has to become blocked. So let's say that a developer, in that same example of that integrating party wait time, let's say, they are not picking up just a single story, or they picked up a single story, started developing on it, noticed that they still had to wait until a depending team needed to deliver some stuff. They decide to pick up new work. What will happen is, maybe that new work also is dependent on something else. At that point in time, it also becomes blocked. And then you just keep on increasing lead time or increasing work in progress. And as we saw before, because of the indication of work in progress being an indicator for delaying lead time, here this is like the graph to show that behavior, all of your stories will end up being delayed longer. So it might be smarter to just not pick up those items that you're depending on one team with in the first place. But the other thing is, even if you did and you learned about it, it's still not a good idea to pick up new work. It will be better to invest in learning or making your code a bit more robust by, I don't know, like increasing the amount of coverage in your code, or of your code base, or refactoring some stuff that you've always wanted to do, because it's like the typical thing, like, oh, we've got something working, but actually it's not really that great to keep on maintaining it for in the future. So that might be like a great time to actually start doing that kind of work. And then try to make sure that you finish that, of course, before that other team is finished with their job, so that you can continue working on that dependent story. All right, that's, I think, all I had to share about that. Like, maybe there are some other questions there that I can try and answer. Yeah, maybe I still wanted to share some knowledge on T-shaped person. There we go. Michel, the man himself. I hope you didn't mind me sharing this. I think it's just too important to not talk about. And I was waiting for the DDD Europe talk to come up, but I still haven't seen it yet. So yeah. Thank you for sharing, actually. It's really, really great. So here we go. T-shaped profiles, what are they? So imagine that a person, let's say me, let's just take me. My base knowledge and skills is in one topic maybe, and my depth is, I don't know, maybe in coding, for example. So I'm good at coding, so I'll get like a 1 bar here that's very deep for me. But of course this is a bit unrealistic, but it's sort of, maybe this is like an excellent graph here. So an I-shaped person, expert at one thing, specialists we usually call them as well. And then very broad, they're capable in a lot of things but not expert in any. So these are generalists. And then we've got T-shaped profile. So they're basically generalists, but they're very good at one thing, for example. I think these are, in fact, nowadays, I think most of our profiles that, at least that I work with, they're more or less T-shaped profiles. So If you've got a tester, they will also be pretty good at developing because they understand how to write code in Gatling, for example, to drive high performance tests, for example. And then there's also a new terminology called E-shaped. Maybe if, here we go, or comb shaped. So basically it's when you've got more depth basically and or more specializations. That's basically the idea there. Yeah, that's about it. That's, I think, all I had to share. Yeah. All right. Let me know if you have some questions, and then I will enjoy a sip of my Karmeliet. Of course, this will come up also on the YouTubes. Maybe I'll share a link. I don't actually have a playlist yet, so I plan on adding a playlist for that. The YouTubes. How do I make sure that nothing starts playing? Let's see. Yeah. I figure if you just go to youtube.com/ and then my name, just like I added, actually it should work. I haven't actually tested it at all, but I guess it should work. Yeah, there we go. What's up, Dota Attitude? Dota 2 Attitude. There we go. I'll tell you what's up. I just finished a talk about explaining the importance of flow. You just got your school project hosted. That's great. Where and what is it? What do you think about Kanban versus Scrum? This is a very interesting question. So, for me, it's the difference between Kanban and Scrum is really where do you mark your cadence. And I feel like with Kanban, you don't care about it as much because you're starting to focus on flow a lot more. But with Scrum, it's you also sort of focus on flow, but you only measure it after 2 weeks. That's the only difference. So even if you work Scrum, or whether you work Scrum or you work Kanban, as long as you're measuring the right things, aka lead time, then you can work however you want. I don't care at all. So that's my thoughts on Kanban versus Scrum. Personally, I feel that Kanban is more, how do you say, like it's more aligned with how I feel work comes in the system or comes in towards your team. Because even if you're working just pure feature development, you're still getting new bugs or some operation stuff you need to do, or like those small things. It still makes more sense to me to work Kanban than Scrum, because the fact that typically the one thing I don't like about Scrum is that it requires planning, right? And to do planning, you need to somehow know how fast you're going or how much work you can pull in for the next couple of weeks. When I generally don't care about that. I just want to go fast and keep on going fast. And you can do the same thing with Kanban. So even without planning, you can still go fast and improve on that, in fact, if you measure the right things. So that's about the stuff I think about. Yeah. Gaga Black, thank you for following. Yeah. Maybe another thing I wanted to say is if you know about the Schneider model, I think it's called. Maybe it's not the Schneider model. Oh, I think it is, in fact. Here we go. Oh, wait. I wasn't sharing anymore. Hang on. Let me share this one thing real quick. So in this little book called Agile Adoption Culture Guide by Michael Sahota, I will link in chat real fast. He talks about using the Schneider model to define cultures basically, and then to increase or the chances of an agile adoption. So that was agile when it wasn't, when it didn't leave a bad taste in your mouth, let's say. So it's the current agility, maybe, I don't really know. But in that little booklet, he talks about if you have identified a more command and control culture with the company that you're trying to implement agile adoption, then introducing Kanban will increase your chances, basically, is what he's saying. The reason for that being that because you can really like very fine-grainedly control what you're working on by limiting the work in progress, this sort of aligns with the idea of having a command and control culture, basically. So it should work better. Let me look that thing up about Michael Sahota's Sahota Agile Adoption Guider. Yeah, there we go. So this is the InfoQ PDF. It's freely available here. It's very interesting to read. It's just 80 pages, I think, but like I read it such a long time ago, but here, Kanban as a Trojan horse or gateway drug. I mean, come on, how can you not like this? Yeah, so very good stuff. And Motoko Hadahi, you feel the same? I work for multiple companies and always Scrum, and never I feel it to be great. Yeah, I've got the same problem or issue, I don't know how you call that. But yeah, just working Scrum, there is a good thing to it as well. If you can make sure that your team really like actually focuses on getting work done, then Scrum, I think, can work very, very good. But if you know, like the typical following the checkboxes guide, now we're doing Agile, being are we doing stand-ups? Check. Do we do retrospectives? Check. Do we do planning meetings? Check. Now we are Agile. Yeah, you're not Agile, you're just following some methodology. I mean, lots of people forget or like don't realize that it comes with a change of mindset, and if you don't nurture this mindset, then you will fail. Then we will move into the faux agile, how do you say, like the culture or meta. It's not a place you want to be at. But yeah, thanks for asking that question. And then it's on DigitalOcean, you mentioned Dota 2 Attitude. That's cool. Yeah, I hope this was useful. If you've got any other feedback, yeah, just let me know. And even in the comments on YouTube or here or however. Yeah. Cool. I think I'm gonna call it the end of the stream then. And normally I would stream again every Tuesday, but next Tuesday there's the Lean Coffee meetup that I'm hosting anyway, so I still have some time to prepare that. And so that means I won't be streaming on next Tuesday is what I'm trying to say. Oh, thank you so much for the cheers. Thank you so much. But yeah, so normally I'll try. I don't really know when I'm going to do these special things, but Usually they will be on Sundays, aside from our regular streamage. So yeah, there you go. Thank you for participating, and you too enjoy your day. All right, that's it for me, and then see you next time. Deuces.